Hi, it's time for a video repair. So what we have today is we have a NuTone model NM100. The NM100 is the same as the Music and Sound or M&S Systems DMC3-4. It's a 3-wire or 4-wire system, and they were both primarily designed to replace older 3 and 4 wire systems. This is somewhat of a mystery unit. It was sent in by one of our NuTone dealer customers, and they were asked to go out and look at it. It came from a house that's about 3 or 4 years old. The house went through a foreclosure, and the new buyers have hired a contractor to renovate the house before they move in. So the only real information that he could tell me about it was dead. And when he said it was dead, he meant everything was dead, nothing worked at all, and he doesn't do component level repair, so he sends his sets to me. So I have it set up here just to take a look at it to see what it is. I haven't done anything other than set up a little system here so we can try it out and see what dead actually means. So what I've got is, I've got it set up attached to a standard NuTone AM/FM dipole antenna. I've got it connected to a chime module here. I don't know whether or not it had a chime module in its original installation. He didn't send one in with it, so that's our chime module, which I know is good and it does work. A chime module wouldn't make a set go dead, so that's all fair. Whether he's got a chime module problem or not, I don't know. I have it connected to a single entry door station, and I have it connected to a single 3-wire inside remote station. So that's enough for testing purposes. You don't need to do more than that at this point. At the end, when we finally get it working, we'll add some more inside speakers to it and test from speaker to speaker and do all that sort of stuff. So as a brief overview of the NM100, it's AM/FM radio with room-to-room intercom and built-in door chime. The room control switches are behind the left-hand door here, and we'll make sure everything is in the radio intercom positions. I have this all set up, but I haven't actually hooked it up or turned it on yet, so you get to see me do it first time. The other thing that he did send with it was the power transformer, and that's what we're going to look at first. So the whole idea behind working on a set like this, especially a newer model that we haven't done as many of as we have all the other models, is you want to become quick and efficient about narrowing down where the primary problem would be located. And the standard rule for doing that is the first thing you do is you check voltages, because if you don't have power, then you don't have anything good after that. I have the transformer wired up to my bench AC power supply just because that's easy, and we'll go ahead and turn it on. And I will put the multimeter on AC volts, and the NM100 power transformer, which is a model NA300TA. I don't know what the M&S or Music and Sound model number, but they're the same. It has 2 outputs. They're both supposed to be 18 volts. And if we check between pins 1 and 2, we should have 18 volts, and we have nothing, 0. And then if you check between pins 3 and 5, we should also have 18 volts, and we have 0. And just to make sure, let's check our power supply voltage here, just in case. You never know. 114.6, just like what we would want it to be. So the transformer is not putting out any power, which means that the 2 internal fuses inside the transformer have blown, and that could be as a result of a problem with the NM100 where it overloaded the fuses and they blew, or it could be unrelated altogether and it's just a dead transformer. So what we're going to do is we're going to substitute his transformer for my shop transformer, same exact model. Now it's wired up on a power cord, so we'll go ahead and plug this in. And just to keep everything even, we'll measure the voltages. Pins 1 and 2, 18 volts dead on. Pins 3 and 5, 17.9, 18, close enough. So this is a known good transformer. If you want to measure or check the voltages on your transformer, there's a little legend right here on the label on the top of the transformer plate, and it shows you which which pins in the socket are 1 through 5, and what the voltages are listed right here, so it's easy enough to do. Even though the transformer he sent me is dead right now, the fuses inside of it are replaceable, so that's something that we can repair for him before we send the set back. So the next decision here is, this is where it gets a little tricky. So do we want to take our known good transformer and plug it into a mystery set to see what happens? If the original transformer is dead because of a problem with this, then we could blow the fuses in this transformer. It's not the end of the world because I have a bunch of these and I'm the guy that can fix the fuses, so we'll take the chance. What I need to do is make up one of these transformers without fuses, and that way you don't have to worry about that. So we'll unplug it. One of the things you have to remember on these models, on the NM series and the DMC series, is you should never connect or disconnect the master station from the transformer while it's powered up. That sudden voltage or current surge when you plug the two halves of the plug together can temporarily overload the fuses. You get this voltage surge and it'll pop the fuse, and then your transformer goes dead and it becomes a 3-pound brick. So always turn your circuit breaker off. So we'll go ahead and connect it up, and we'll put it over here in the front so you can see it. And we'll plug this in. Okay, so I heard a little blip on the speaker. However, if I turn the light off, there's nothing on the display, it's blank. So either it's got a problem or it immediately blew the fuses in our transformer. So we can check the voltages on our transformer while it's powered up and plugged into the master. We'll just put our probe ends in the other end here, and this is only 18 volts, so it's safe. So I'm getting on 1 and 2, we're getting 17.8, which is fine because it's a nominal 18 volts, and on pins 3 and 5 also 17.8. So that means that our transformer is still working. Whatever's wrong with the master station, at least at the moment, is not blowing the fuses in our good transformer, but we have nothing on the screen. So the next thing we're going to do in moving along, this is what I refer to as intercom triage, which is going through the basic blocks of the master station to see if you can narrow down the problem quickly so you can get on with the actual repair. So what we're going to do next is, on both the NM series and the DMC series, there are 2 fuses on the power supply amplifier board, and we're going to check those next. Right, so I've got the set turned over. It's sitting on a rag so we don't scratch up the front because cosmetically it's in really good shape. And what you're looking at here are a close-up of the 2 fuses. There's F1 and F2 for fuse 1 and fuse 2. Off the top of my head, I don't remember what the rating for these are. I think they're 3 amp. Yeah, in fact it says 3 amps each. They're both the same, and so we put our multimeter on continuity, so when we have a connection it beeps, and all you have to do is measure across the ends of the fuse. Now when you do this, you have to have the transformer unplugged. You don't check fuses while the set is powered up because you can damage your multimeter, and we don't want to do that. So we'll just put one probe here and another probe here, and it beeps. That tells us the fuse is good, and we'll check the second one, and that tells us that fuse is good also. So we know it's not the dead transformer that came in, and we know it's not the fuses. So now we get to go on to more elaborate things to check. Right, so I stripped away all the miscellaneous paraphernalia. I took off the antenna, I took off the door speaker wires, I took off the 3-conductor wire from the remote speaker, and I got rid of the chime module because at this point they're not doing us any good and they're just in the way. The other thing we're going to do is we're going to take off this green support strap because all it's there to do is hold the unit up when you're installing it, and right now we're more worried about getting it working, and it's kind of always in the way. So we'll take that off and put that away. Make sure you put your screws in a cup because otherwise you'll lose them. Now, since we have nothing on the master station, like I said, it did make a little blippy noise when we powered up my shop transformer, so it has some small sounds of life, but certainly not enough to actually operate. The first thing we're going to do is we're going to look at the power supply amplifier board, because that would be the first thing. If you're checking voltages, that's the first thing you want to do. And to make this a little easier, and because it is relatively easy, we're going to take off the AM/FM tuner module, because again, it's kind of in the way. It's on this big bracket right here, and it covers up half of the board, and there's no reason to really work underneath it when you can just unscrew 4 screws and take it away, put it off to the side. And then we can also remove the big aluminum heatsink, and we'll put that off to the side. And now we can see the actual whole board. So before we actually take the board out, one of the things I like to do is I like to just do a quick visual inspection and see if we got something that looks like it might actually be like blown up and exploded. And I don't really see any blown up or exploded. Unfortunately, sometimes when you do, that helps. So what we're going to do now is we're going to remove the power supply amplifier board from the master station. It's held on with these little clip standoffs. There are 7. There's 3 at the bottom and 4 at the top, and these are kind of a pain in the neck to do. If you take a small nut driver, you can push it over the top of it, which will push the locking ears in, and then you use another one to sort of pop it up past the ears. Maybe, yeah, that's better. And these are a little tricky to do, because as you work across trying to release each one, the one you just released, like I just did the one on the end here, it wants to, the board moves around and it wants to lock back in. So sometimes you end up having to go around and around a few times. I have a feeling that it's the kind of thing that as we do more and more of these, we'll probably get better and better at it. I remember, see now the top ones, I'm doing the top now, and the bottom ones I've heard some of them sort of lock back in. So I remember the first time I had to take a 4406 apart. It's like, God, there's a lot of screws. And you sort of get used to it after a while. Alright, so there's our power supply amplifier module. I don't see anything blown up on it, and it certainly is worthy of testing. But first, since we're sort of doing rapid triage, we want to move along quicker than that, so let me go get something. Right, so are we seeing double? Is this stereophonic YouTube video? No, it's not. This is our shop NM100 music and sound DMC3-4 power module, and this is the original one that we just took out. And what we're going to do really quickly here is we're going to substitute mine for theirs and see if the set comes on, because this is a really fast way of narrowing down where the problem is. If it still doesn't work with the known good module, then it could be a problem on the main audio intercom board, or it could be a problem with this board and that board, but at least we're moving in the right direction. One of the things we do is I always mark the original board, and all I do is put a red dot on it, because these are essentially identical and you don't want to get them mixed up. So we'll take the bad one and we'll put it off to the side, keep it out of the way, and now we'll go ahead and put this one back in. If we're a little careful and we get the pins all lined up correctly, because it looks like one of them is a little tweaked here. This has a 30-pin header on the back of it, right here, 30-pin header, and it plugs into its mating socket right here, and 30 little pins that are about 3/4 of an inch long each are easy to get bent. So we'll probably have to actually get a piece of non-conductive foam. I'm sorry, conductive foam is what we really want. And we'll make a little block to put over these, so when it's in its bin, they don't get bent out of shape like they are now a little bit. Alright, see if we can get this lined up here. This is a little bit tricky because it's a little hard to see. And I think what I need are my magnifiers so I can actually see what I'm doing. Because if you don't plug it in, then even if you power it up, it's not going to power up the rest of the set and nothing's going to work properly. Yeah, it's going to be troublesome. I'll be right back. Alright, I'm back. So after much fooling around to get all the pins lined up, I actually did get it popped in, and we definitely are going to have to do something to protect the pins so they don't get bent and they're not aligned correctly, because that was a total pain in the neck. So let's go ahead and connect it up to our power, and we'll go ahead and plug our transformer in and see what we get. Now, same thing. It made the blippy noise as soon as the transformer powered up, and we have nothing on the display screen. So we'll just do a quick check of our voltage out of the transformer. You always have to check and recheck. You don't want to assume, oh, I checked the transformer last time, it was fine, so it's probably still fine. Okay, so now both outputs on the transformer, before we had 17.8 volts, now we have 17.1 volts, which means something's drawing more power from the transformer than it did before, but we still don't have anything on the display. So what I'm going to do next is we're going to unplug it, and now we're going to disassemble the whole thing because that'll make it easier to work on. Okay, I've got it all taken apart. So these are the three boards out of an NM100. They're the same boards that are in a DMC3-4. And one of the nice things about this particular design is it's relatively easy to take apart, and also once you have it taken apart, it's actually easier to sort of put it together out of the faceplate, and that makes it easier to work on. This is our microprocessor display board. That's the main board. This is our audio intercom board, and here's our power amplifier power supply module. And what we're going to do is, we already know that these three as a set don't work. So what we're going to do is we're going to one by one substitute them with boards that I know that are good, again in the attempt to just narrow it down quickly. So what I'm going to do is the original audio intercom board, it gets a red dot, and we'll put that out of the way because we don't want to get our boards mixed up. It's amazing how easily that is to do. So we plug the display microprocessor board, plugs into the audio intercom board like this. And then we'll put our power supply board back on. Hopefully this will be easier than the last time I did it. Or not. Some of the pins are still somewhat bent, and that makes it hard. It's a lot of pins to line up. They fit fairly tightly, and so it's really a matter of going back and sort of tweaking each one or each set. It looks like the ones on the ends get bent easier than the ones in the middle, because when you sit it down it leans on it. So definitely going to have to get a piece of foam or something to put over them once we get it all lined back up. There seems to be one that wants to keep hanging up at the other end. Ah, there it goes. Alright, so now it's plugged back together like this. This is what I call Frankenstein mode. Not really the real deal, but it'll work. It makes it easier, and you don't run the risk of scratching up the customer's faceplate, which you don't want to do because faceplates are not available. So put a big old scratch in it, then they're going to be mad at you. So we'll go ahead and power it up, and you see, I think you can. And we got nothing, and I didn't even hear a little blip that time. So just for good measure, Let's check our voltages really quick. And we've got 17.1 and 17.1. So the transformer is still okay. Go ahead and unplug it. So we'll take it, I'm going to take it, well, no, I'm not going to take it apart yet. So what I'm going to do is we'll take off the microprocessor board. We'll put a dot on that one to keep it straight. And we'll get another one and plug this in like that. And now we'll power it back up. And we have a clock. So apparently the problem is on the microprocessor display board. So that's how quickly we can sort of narrow this down. Now, all things being even, we're making a lot of grand assumptions here. And now what we need to do is we need to work backwards just a little bit and put the original power supply amplifier module back on the original audio board, and then plug this microprocessor display board into it to make sure those boards from the original set are still both good. So that's what I'm going to do right now. Alright, so now we have my replacement display microprocessor board. Here's the original one that came out of the set, and here you can see the red dot I put on it to keep it straight. And we have the customer's original audio intercom board and the customer's original power supply amplifier module, and I have it plugged into the transformer. And if we plug the set in, it lights up to 1202, which is what we want it to do. So the next thing we're going to do, just to make sure we're still on the right track and everything should work out, is we're going to hook the tuner back up to it. I did take the antenna off, so I have to put that back on real quick. This goes this way. See, you really want to know, because at this point it would be a mistake to say, oh, well, that's probably the only problem with it, but you don't really know that. One of the rules of good troubleshooting is, and I was taught this a long time ago, it's test and verify, never assume. Because as soon as you make an assumption, then you could be wrong. We need a speaker cone to plug into it, so we'll just use the original Master Station faceplate here. And make sure all the switches are right, and see how good we are about our controls. So power came on, it came on in the auxiliary source, which is what it's supposed to do. There's FM, turn the volume up, we'll tune. See if we can find a station. We got music. So while we're not testing every single function that there is, it's probably good enough at this moment to make a educated guess that we have a problem on the display microprocessor board. So let me get this all moved out of the way and we'll take a look at it. Okay, so I cleared off the workbench. I got rid of all the miscellaneous stuff that was in the way because I don't like a cluttered workbench. And now let's take a look at what we've got here. So this was the setup. This is the original amplifier power supply module. This is the original audio intercom board, and this is the original display board. There's the red dot. I have it hooked up to the transformer, and if we plug it in, we don't get anything. And we already know that if we substitute a known good microprocessor display board, it comes on and it plays the radio, which means most likely everything else is okay. Oh, we'll find out at the end, but it's a good, safe assumption. So the problem is with this board. So what could the problems be? This is where you have to look at what clues you have before you start spending a whole lot of time scrutinizing the board. So let's talk about first, what does this board do? Well, down here is the microprocessor, and the microprocessor is the brain of the system, and it supplies all of the information that's shown up on the display, and it controls the functions of the intercom system. So if there's a microprocessor problem, if the chip is bad, or if the firmware inside of it is corrupted, so it's jumbled up and it's missing pieces, it doesn't know how to operate. So for the most part, it doesn't do anything. And if that's the case, like on other models that have microprocessors or microcontrollers, is a more accurate name for it. If this is bad, it's done. You need a replacement board, because while this particular microcontroller chip is something I can order, probably costs $4 or $5, something like that, and it's easy enough to mount it onto the board here, there is no provision. Well, there actually is a provision to program it. There is a header that could be installed over here and hooked up to a computer, but to program it, you actually have to have the program. And there is no program available, and NuTone's not going to give that out. Even if they do have it, who knows if they do anymore or not. So they're not going to give away the program. And also, just to answer the question that a lot of people ask is, well, isn't there a way you can hook up to it and you can take a good board and download the program out of the microcontroller onto a computer and then copy it and upload it into a blank one? No, it doesn't work that way. Microcontrollers like this, they have part of what's inside here are referred to as fuses, and when one of these is programmed for the very first time, at the end of the programming, they send an impulse into the chip and it blows the fuse and it closes it, so you can't download the information out of it. And if you try to do that on a known good one, you will erase the program out of the chip. And that's for intellectual property protection for the program and all like that, because, you know, everybody wants to copy and bootleg NuTone intercom firmware, because there's a big market for that. So, but no, you can't easily copy the chip. There actually are ways, and there actually are companies that know how to work around that and are able to do that, but it's prohibitively expensive, and none of you are going to pay for a chip that came from a source like that, because it's just too much money. So that's not a viable option. Now, what else do we know about this? I did a quick visual inspection of this board before I put this all back together, and I didn't see any components that are exploded or burned or look like they got hot. Although in modern lower voltage systems, you don't usually see that much anymore unless something really dramatic happened to it. So that's not going to give you a lot of clues, but there is a clue. So I'm going to go ahead and plug this back in. I'm going to plug the transformer back in. And just like before, it does nothing. Now, it does nothing, so here's the way you have to look at this. All of the information that should be on the display right now, where it should be flashing 12:05 or something like that, and it'll be blinking at us, all of that information comes from the microcontroller. But there's nothing on the screen, so you think, oh, it's all blown up. But maybe not, because the other thing that's missing on this board right now is when you power up an NM series or a DMC series, the little backlight LEDs right here and right here should be turned on, and they're not. So what does that tell us? Well, it could be that the LEDs are burned out, or it could be something else. So that's an easy enough thing to check. We unplug the transformer and we take our multimeter on diode mode and we probe, wrong way around probably, and we probe the diode, the LED. If they're good, they should light up, and they're not. Now, I'm a ways away from this, so it's a little hard for me to see. Oh, no, wait, we got a flash. See if we can find it. It's hard to do. It's hard to see. Okay, so I think you can see that. See the glowing light out of the LED? On, off, on, off, on, off. That one's okay. On, off, on, off, on, off. So we know the LEDs are good because the multimeter in diode mode will light them up. So we know those are good. And if we plug in the transformer again, they don't light up. So what does this tell us? Well, could it be that the microcontroller controls the power supply to the LEDs and that's why they're not lighting up? Well, yes, kind of in a way, because there are 3 light levels that are adjustable on a DMC or an NM series, and by pushing the tuning up and the power button simultaneously, you can scroll through the 3 settings, which is basically low, medium, and high. Now, what's doing that? Well, the microcontroller is doing that. So you're changing settings in the microcontroller that are changing the voltage output that goes, or the PWM signal, to make them light up at different levels. That's not working because probably either it could be that the microcontroller is bad, but it also could be that for some reason some other part of this board has a problem and basically the board's not turning on. So if the board's not being powered correctly, then the microcontroller isn't being powered correctly, which means it's not turning on. And one of the things about microcontrollers is they're very, very fussy about the voltage that makes them turn on. And if it's not right, they don't turn on. So it could be that there's a power issue on this board and that's preventing the microcontroller from turning on, which is why the screen is blank, why the LEDs don't light up, and nothing else works. So this takes a certain amount of component troubleshooting to do, which is not very interesting to do in a video. It's time to get out my super secret schematics, which somebody sent to me, and I actually had them printed on big sheets. So standard size, they were 8.5 by 11. We had them printed out on 2-foot by 3-foot sheets. So they're really big and really easy to read, and there's places to make notes and things because that's how you learn. So for this part of this video, this is the end. There'll be a follow-up to this video. It's not going to be a second part. It'll be a follow-up to this repair because it's Friday afternoon and I'm not going to start diagnosing a board like this right now. It's almost time to go home. So watch out for part 2. I hope so far you found this interesting and perhaps helpful. If you did, please give it a big thumbs up on YouTube because that always helps. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address, and every time we post a new video, you'll get a notification and you can watch it. Watch for the follow-up video where I'll go through what I found wrong with this board, what it took to actually fix it. If it is repairable, it may not be. I don't know yet. We haven't done enough of these to actually know too much about them. Then you'll get to see it work and we'll put it all back together because I know the customer wants it back. So that's all for today. See you on the next video.